Hi everyone, welcome back to my channel. My name is Gaurav, and in this today video, we are going to learn about Docker basics. This is the topic of the today tutorial, or you can say the video. So, what we are going to discuss in this video is your Docker basic, how Docker came into the picture, what is the use of it, right? Because nowadays Docker is used everywhere. A lot of other alternative of Docker is came into the picture, but yeah, still Docker used a lot, and it makes the developer as well as the DevOps engineer life very easy. So we'll see that, and we'll start from very basic, like why we use Docker, or like the topic will be why, how the Docker came into the picture. So how Docker came into the picture. This is the question, right? Now let me make this clear because this is very annoying right now. So how Docker came into the picture, right? So to discuss about that, first of all, in initial days, right? I think before Docker, how people share software or how people give software to people is that first way is that in some languages, like we have something like a build, right? You can build a program and you can build and share that program to some person, right? So for example, if I give you, if you have used C++, Java or something like that, what you can do now, you can compile these codes and you can create a binary and you can share that binary to the respective person. But the issue is that because what these languages do is that they use all the packages and they make a particular what I can say, a particular binary which it could be used. This is very similar case nowadays with Golang, where everything will be packaged in one single binary and you can run it anywhere. Though running the Java is very different case, and this is not the part of this video. So more or less what we do is that we build the program, we share it with the respective person. The respective person, what it do, it person will execute that in their personal PC, right, or laptop. Now the thing is that with these languages it will be working fine, but when you develop actual software, for example in the languages like your Node.js, right, uh, where a lot of external libraries that you use, right? The language like Python, where a lot of heavy libraries are there, right? So in that case, what happened that when previously people used to share the application, whether it's on Node.js, whether it's on Python, or even though in the Java, if you go to the Spring Boot or these frameworks and libraries, now with that you have to share a code, right? You have to share the external library code also, uh, external libraries. Now what happened with those libraries is that what we are talking is that we have the external libraries that we use, right? Now these external libraries, definitely they have their code in it, right? And they maintain some versioning, right? There is a versioning, right? Like version 1, version 2, or something like that. They used to release that. Now if you share, right, your software to someone, so for example there is a person here, you shared a code with him, right? You shared a code with him, with which will work if you use, let's say, for example, let's say JWT is there. JWT version 1 only works with your code. If you upgrade it to the version 2, the things will break, right? So when previously when we share, as I told you, we are sharing with the binary, or we make the build and we share it to the particular person, right? Now the second way what we do is that we share the direct code. So this is the second version, that where what we do is that we directly share a code with the user try to do all the setup on their system, and then they install all the dependencies, everything that is required for your code to run. He set up the environment and then he execute it and test it. Now because as you can see that even though there is one mistake or anything happened to the external library, or whether the dependencies issues or anything that is not properly installed, your program will crash. So the initial reason for it, for the Docker, is that why Docker is built. Docker is built because to share or package your programs, right? To share or package programs with proper dependencies, right? Right. So we got to know that, okay, we have not discussed what is Docker yet, right? We have discussed why Docker came into the picture. So Docker is your Docker is not a very single application, or it's not a single application that you will install and everything will work. Docker is a group of application, you can say. So in the Docker itself, if I tell you, let's go to the definition of Docker right now. So if I take a space, let's say Docker, right? And if I go below, you see Docker will have a Docker hub, right? Docker will have a CLI that you will use. So the commands that you write, Docker ps, Docker ls, something like that, we also see that. And we have an engine, right? Because Docker is something that you will install in a system, and then that Docker will manage everything. Now what Docker do is that it containerize your application. Forget about the spelling, but it containerize your application, and it help us to manage your containers and containerize your application. So what do you mean by containerization? What do you mean by containers, right? We'll discuss that first, and then we'll discuss these three parts. So what is container? Container is something you can assume, like I will draw an image of container. This is a container, right? And this container is nothing but your application, right? Now if you see this application actually sitting on top of your operating system. There is a OS, and in top of your OS, in your system, right? Whether you have Windows, whether you have OS, Mac OS or anything, right? On top of that, the Docker layer will sit, right? The Docker engine that you are installing. So here what will happen is that there is a Docker engine that will come. It will sit here. OS is there. And it on top of that, it manage all your containers. It create containers on top of this layer. So here, as you can see, these containers are very isolated. These are isolated. A lot of things we call it isolated, but a lot under the hood, it uses the resources of OS only. It is isolated from your operating system. So nothing will be installed, nothing will be done on your OS thing. Everything will be done in a container. Everything will be done on the container, and after that you can delete also, or you can destroy it after the use. So this is how the actual architecture looks like, where there's the lowest layer is the OS. Then there's a Docker engine which actually talks to your operating system, and then also manages the container and try to make a communication between OS and your containers. So it's kind of the bridge. So we discussed about engine, right? So how engine is going, it's making the bridge. Now container is like your actual application that is running and run by the engine. Now coming to the next part, which is CLI. CLI is nothing but the tool that you will use to maintain, to operate on your containers, or to actually instruct user, or actually to talk Docker engine. So you can assume it anyway, that either you are talking to your Docker engine. Basically we are talking to Docker engine only. The CLI will do what it will do. It will send commands to Docker engine that, hey, can you list all the containers in my system? Now Docker engine will take that command, it will coordinate and these things, and then it will be giving you the response. Now talking about Docker Hub, right? So its spelling is very bad. not spelling, the writing is very bad. So let's say Docker Hub, it's hub. So if you go dockerhub.com, then this is a public repository, public and it's a repository. You can say public plus private repository, where what you can do, you can store your images. Now, what is images? Let's understand that. Now, what is image? Image is like the packaged application. So I will write it here. Packaged application. My bad. Let me do one thing. Packaged application. Now coming here, you will see that now we're talking, it's a packaged application. So what will happen? You have written your code, right? This is your code. Now if you want to share this code, you don't want to share your code like actual coding. You just want that, is there any way I can package this code and I can share it with someone who can test it or do anything with that, right? Do anything. Now, is there any way to do that? So right now, previously we don't have any solution such like that, or even though if that exists, I don't have any knowledge about it. But more or less, the issue about this is this only, that there is no way to package your application and send it until unless if you are building an enterprise application, right? Then you don't have the option. If you are writing a single file, let's say C++ file or Java file, you can definitely compile it and share it with someone. But when you build a software, it's not single file. It's not like only your library that you are using, right? There are like a lot of external libraries are there. So in that case, you will have to package your application and share it with someone. So you have your code, right, with you, and you want to share it with someone. Now image, what image is that? Image is the packaged application. So what you do, with the help of Docker, you create an image. Now this code will be converted into the image. Now how this image will be generated, right? So there are specific commands that you will get on Docker. Let me write properly. Commands that you will get on Docker that will help you to create the image. Now there is something called as Dockerfile also that we will discuss later. But Dockerfile is your set of instructions that will tell Docker to actually Docker CLI to what steps he has to do. So for example, if you want to create image, now from your code, you want to copy the code, then you want something to be executed. There will be something language specific images needed. So for example, if your code is written in Node.js, now you need Node.js environment to run it. So in Dockerfile, you will define your image, right? The base image. We call it as a base image because your code will be run on the Node.js. So you will define the base image, right? So let me write base image. Then there are some execution of there are some copying, dependency installation, something like that will happen. Then there is a actual run of the program. So every different application have the different command to run it. So you will mention that and a lot of other stuff that you can do with the Docker file. So to create image, we need the Docker CLI so that we can fire the commands, and we need a Docker file that will help us to make a image of it. So that's the thing. That's how you can actually create your own custom image, right? So there are two kinds of image. There is a base image that is already created by someone. You are using it in your Docker file to create image on top, to create your image on top of that, right? So here we are creating, so we call it as a custom image. So right now we are creating the image. Here is the custom image because we are using our own code. We are using some base images, and then we are like creating an image. So to summarize it, image is nothing but the packaged application, and how to create the image I will show you in the later part of the video with like how you can do that. Yeah, so we understand image. What is image? Now, moving forward, we have to understand how actually containers are built on that. So I will give you a example with that. Let me draw a diagram of, let's say this is the image. For now, my diagram is like very bad, but this is a Node.js application, right? We are assuming that, and this is the image of a Node.js application. What it does nothing. On slash hello, it will greet you. Okay, so there is an endpoint. This is a backend application where on slash endpoint, very bad, on slash endpoint, what you will do is that it will greet you, like say hello, how are you doing, something like that. Now this is the image that we have generated, and the process of image generation, I already told you that we'll use the Docker file to do that, and there are some commands that we have to use. I will show you also how you can actually create an image, right? We'll see the example. But now this is the image, right? Now what happens when you create a containers? You can create multiple containers, as many as you want, until unless you have the resource to create that. So so what will happen that we fire some command from Docker, right? So there is a CLI command that will be fired with help of Docker CLI. But now that what that will be doing is that will be doing something like this. It will create a container. So you can assume this is a container. This is a container. I should be making this one. So this is the container, and in this container, basically there is a layer that is attached to it, is called as image. So you can say that when you create a container, an image layer will be attached. So this image will be attached to it. Now other things will be happening on the container, like port forwarding and these things is managed by definitely on the Docker container. And one thing I forgot to mention is that Docker engine manage a lot of things. For example, the networking, right? If there are two applications, right, there are two containers, how the two containers will contain, it could be like you have two containers, for example this, and it also has the image, but this image is very different. This is a front end image. Now this front end wants to call to this your backend container. How it will be doing, right? So it maintains like the networking, the communication, the life cycle, and stuff like that. I will attach a detailed documentation about like what exactly it manage, but more or less it manage networking, life cycle of containers, image creation, image management, and stuff like that. Also it create the layer between the your operating system and the actual container, so that you don't have to do a lot of work, right? And it's create isolation. Now this is so we know this is a container, this is a container 2, right? Container 2 and container 1. Now this is the front end application, this is a back end application, right? Now the front end calls backend, so these communication will be handled by your Docker engine. But this container is very much isolated. This is very isolated, right? This container will have their own resource, right? Resource says, let's say if you assign this container one CPU, it will use one CPU and the memory that you will assign. If your application exceed that limit, right, what will happen is that this application will keep crashing and keep restarting. So these logic is automatically handled, you don't have to do anything. So that's a very good thing. Same with your Docker container, another container also, if you assign one CPU, it will use one CPU and the memory here, right? So it's this way, it's very isolated. And if you see this, right, this is something seems like VM, right? In the VM also, you on top of your operating system, we actually deploy a VM, right? We create a VM, so you can create multiple VMs, but as VM has their own operating system, right? This is very important point, that containers will not have no separate OS. Container. So container don't have any separate OS. whereas the VM have separate OS. So let's write this. VM needs, not needs, it have separate OS, and because of that VMs are very large. They are very large in size, but the containers are very small in size. So we remove the operating system layer, and as an operating system, what it uses host operating system. So as you can see that, let's draw the diagram again. If I just go below, right, let me do undo, then we'll do that. Okay, my bad. So we'll do this, and if we have this operating system layer, for example OS, then on top of that we have, let's say, engine, and this engine is the Docker engine, and this is the containers that we have created. You can assume this. So these are the containers, right? Now the engine will use the resources of host operating system. This is your host OS, and this will use the resources of this. The containers resources will be used by so the container using resources that is provided by OS. So and whereas in the VM there is it also using the OS of resources, but there is separate OS layer, right? So which is making the VMs very bigger in size, small startup times. Matlab, if you spin up a VM, it will take more time, whereas spinning a container is very fast. So that's the point that I want to mention here. That this is the very important point. So in the Docker, we discussed 2-3 things. Let me conclude that. First is like we understand about Docker, right? Then we understand about like what is Docker, what is the use of it, and why Docker came into the picture. We learned about image. So image is nothing but the packaged application that you can share with anyone, and the image will have all the dependencies and everything. It's like ready to use. You just spin up the container, you use this image, and then you can able to run the application on your you can run application anywhere, right? So the portability is came here. Now we understand what exactly the container is, right? How it's work. Now we understand that what exactly Docker engine is, right? Then we understand CLI, and then we understand that what your Docker hub is, right? So we understand these things. So I think right now you are like very much clear about these terminologies, right? Now let's get to the main part. Like nowadays, Docker is used for a lot of other things. It's very popular in the DevOps world. Nowadays, the the applications are deployed uh, by containerizing it, and the reason for it is that the first thing that it provide you is that flexibility and portability. So it's very easy for you to build application or to build image and share with anyone, right? And then just you spin up a container anywhere, and then you able to run your application. So the portability and the flexibility that Docker is providing is very great feature of it. The second thing it's provide is less in size. So it's very less in size as compared to VMs and other things. I don't know about other things, but it's very less in size. Like if the VM says in GB, it's in like MB. So it's very lightweight. Containers are like very lightweight, and you have the isolation. So the next point is like isolation. Though this isolation is not very strict, it's not strict, but it's way it's this it's not very strict, but it's provide you a very good level of isolations. Like the library will be installed and everything will be managed in a particular container environment. So it's provide you a very good kind of isolation. So the fourth point that it's provide is less dependencies. Dependencies installations. So this is a very custom point. So it will, so what it will do, you don't have to install dependencies on your system, right? You have the image, right? You have the image. Now you can pull that image, or you can use that image and you can spin up the container. You don't have to install the dependencies. Dependencies and everything is already installed and packaged into the application. You just have to pull the application and then you have to use it. Even though you can customize this images also. So customization in the sense that if you take an example, for example, Node.js, right? So Node.js image is there. You can actually pull the Node.js, and on that image you can run any kind of application. You have everything there. You have image for actual Ubuntu. So there is a very lightweight Ubuntu image is there. You can pull it and then you can use that image and you can do anything that you want to do in the Ubuntu system. So that's the thing that it provide. Apart from this is what I told you, like the flexibility and portability is there, right? It also provide you the easy sharing, right? So it's like it's cover the it's the same thing like the portability. So it's provide you easy sharing of application, right? It's secure, right? You can use private repositories to put your images there, and then you can utilize it to deploy the application. It make easy to deploy application. My bad. Deploy application, because now you can quickly deploy the application. There is no hustle will be there. And apart from this, if I think the scalability is one thing. So now I will explain you how it's very scalable. Apart from this, there is the cold start time is very less. So what is cold start time? I will explain you that. What is scalability? Scalability, and then if you want to scale in the sense, like say right now, if you are running one container, and now if the application load is there and a lot of people is using your application and you want to scale your application, what you can do that you can create multiple containers with that same image, right? So this is container 1, container 2, container 3, container 4, and something like a load balancer you can put, and now the load will be distributed to these containers, and when the traffic will load, we can actually remove the containers also, because the cold start time of these containers is very less. It's significant, but it's way less than the VM. So if you are spinning up a VM, it will take a lot of time, as I told you. So that's the benefit. It's in spinning up a container take around, let's say 30 seconds or a minute, whereas the VM takes around your 30 minutes to actually spin up. And it's also depend on like what kind of a VM it is. So it could be like a lot of VMs are optimized to load in like 15 minutes or something like that. But this is the standard time that like we are assuming around 50 to 30 minutes will be taken by the VM to actually spin up, and whereas the container will take a very less time, because it's actually not copying the image, it's actually referencing to the image. It's just referencing. So as I explained you above, here the same image will be referred by both the containers, though here it's different image, but you can assume that we are referring to the same image. It's not copying it here on the container, it's not copying it here. So what it do is it refers to the image this way, and all the edits that will be happen, it will happen here only. Not those things will not happen here. So you cannot change anything on the containers, on the image, and if you have to do the changes, you have to actually make a new image for of it. So for example, in the Node.js, if you want to add something else, let's say if you want to make an image of Node.js plus JWT included, let's say, then what you have to do, you have to again rebuild the image. It's not like you can add it in the containers. No, this is not the way it will work, because the containers will reference your image all the time. So that's the thing. Because of that, it's start time is less. A lot of other things also, like it's not using it's using host operating system. It's not creating their own operating system. So because of that, it's very fast. So this is the thing. I think I hope this video clears your all the doubt about Docker, and I tried to explain everything what I can do. It's very popular in DevOps, and it's now very popular in developer perspective, because if you want to share an application, you don't want this the front person or someone who is not very technical to do a lot of things. You just want, see, I package this application, you run this application like this, and you are able to perform everything. And so because of that, it's very easy to ship uh, and package application and ship to uh, different places or share to people. So sharing is there. A huge part is there. If you want to share it with someone, the code or the application, you can do it in this way. But nowadays in DevOps, due to its less cold start time, scalability thing, secure, and your dependencies and these isolations less in size, these things make Docker very useful tool for DevOps, as well as the software developers. So I hope I have cleared all your doubts. I hope the topic is very clear to you. After this, I will be showing you the demo of creating the image and how you can spin up a container in your local system. Yeah, so right now, as you can see, I am in Docker Hub. I told you that in Docker Hub, you can create your own images and you can share it. For example, you can see there is an image for Python. So you can use this image to run Python application. So you don't have to install Python on your local system, right? Now what you can do, you can use this image, you can create a container on top of that, and then later on you can delete the image or container, whatever you want. It will not it will not install anything on your system, right? So nothing will break on your system. There are a lot of other things, like you can see Redis, Nginx, BusyBox, Memcached, Alpine, Postgres, MongoDB, all the things, right? Nowadays, everyone uses Docker, uh, Docker to actually ship things. So that's the thing. Right now, I will show you how you can also search about the images. For example, there is a Ubuntu image that you can use, and we also use that. So I will go to the Ubuntu, and then what you can do is that you can actually pull the image. So first of all, what you have to do is that you have to pull the image, or if you don't want to pull the image and then you want directly, if you want to directly run it, there is a way you can use the docker run command that I will definitely show to you guys. Yeah, so here on the image page, you can see that we have the tags here. So you can also see for different operating systems, for different thing, it will be tagging the things. It will also tagging the version that you want. So right now we'll use the latest version that is there of this. And if I just show you that, so for example, I will just do docker ps minus a. So you can see there are containers that are running. So these are my personal containers that is running. So if I also show you the docker images, docker images, you can see that there are these images that I was working on, and these are local ones. So if I just clear this, I will show you how you can do that. So I will first of all pull the Ubuntu image. So I will do docker pull Ubuntu. It's asking for some permission, so I will allow it, ghosty, and so it will take some time, not very much. It depends on your network speed, and once it will complete, so for example, in my case, it's very small image, around 40-50 MB. So it done. So let's see the image, docker p images. When you do that, you will see that there is a Ubuntu version, that is Ubuntu 24.04. It's like previously I downloaded, but the today one is this one, Ubuntu latest is there, and it's around, you can say the content size is 4.4 MB, and the disk uses is this one. So around the size of this is 179 MB in total for this particular Ubuntu image. Now let's run this. So what I will do docker run -d command, because I want to run it in a detach mode, or you can say it. Let's say I want to go with the interactive mode. So docker run -i, and I will give the image name is Ubuntu, and name I will give like my container. So I think image, okay. Oh, my bad. So I think I have to run like this. Yep. So rather than making, because I forgot the command, but yeah. So if you do that, docker run -it. So you can see we are in the docker command. We are in the Ubuntu, sorry. If I do pwd, you can see we are in the root. You can go to, let's say, home, cd home. If I just do, okay, we don't have anything. Okay, let's do this. Let's go back, cd home, cd Ubuntu. As you can see, this is the Ubuntu. Like, I can show you the apt command also. So we can also see the version, that is, this is the Linux Ubuntu. Let's say other information if I want to see. So this is the kernel version that it's showing, 6.12.76. So I think this is what exactly it is. If I just exit it, and if I just show you that, the docker.ps, so you can see there are two Ubuntu containers that was created. The first one is this one, and this was failed, and this was one that we have actually used it. So both the containers, you can see that it's not running right now, but it's in your system. You can delete those ones. Docker remove. You can do that, and then you can copy and paste the container ID, and that will be deleted. So if the container is running, right, you will not able to do that, but as these containers are in stop state, you are able to delete it. Remove the container ID, and as you can see, all the containers will go. So this is how I think you can do that. Now we'll see how you can create the Docker image in your application. Yeah. So right now, I took a demo application to explain you how how the image creation is actually works. So if I just show you that, let me do that. So this is the code, right? And let me do that here also. Yep. So this is the actual demo code. So if you see, there is a node version that is there. The first step is your node version. You can, when you are like building the image, this is the argument, right? So this is the command, and as you can see that this is actually identified as red. So this is a Docker command, arg node version, and this is the point. Now from is there, so this is where we defined actually your node version, the base image that I told you. So this is our base image. Now regarding the structure, right, I'm not, this tutorial don't cover the actual Docker file structure of it, so we'll have a separate video on that. But yeah, so more or less this is a base image that we have defined. Now if I just tell you, like, this is the node env that we are setting up. So env, node env, and the production, this will be actually attached into the container environment. This is a working directory that we are setting. This is something that we are doing to actually optimize and install the dependencies. Then we are creating the user, copying all the files, then exposing on 8 to 8, and then we are running this command, which will actually run our application. Now this expose is, it's very important to understand. So whenever the container will run, right, So the container is exposing some ports. For example, my application. So here, if my application, right, application is running on, let's say, 8080 port, and this is the application port, right? Now, in the container port, you can expose this on any port. Like, for example, I can expose in 5000 port. From 5000 port, what Docker or what containers will do is that when you hit 5000 on your local system, right, it will send your request to 8000 only. So your application is running on 8000, right, based on based on what you have feeded. So for example, if your node application is there, in env you have set the port as 8080, right? This is your application port, right? And there, apart from this, there is a container port. What is container port? Container port is that on which port I can hit the container. So that is 5000. Or you can make it same also. You can make same also. For example, 5000, right? So 5000 or 8080 port, you can do anything. I think you can try it from yourself. It's very easy. You can change the port and you can check it. But just I want to tell you that container port could be different, application port could be different, but whatever the container port will be, you have to hit that port from your local host. So we'll see that. Let's see how it's working right now, how we can build the image. So what we have to do is that we have to use Docker. Let me bigger the size of it. Docker build -c. So there is a tag, right, that you have to say. You have to tag it application, for example, version 1, version 2, something like that, or latest, right? So Docker build -tag, what we'll do is that I will give the image name. Now image name is like, for example, hello example, and this is the latest version of it. And then what I will do is that, sorry, I forgot to provide the Docker file path. So Docker file is currently in our current directory, so I will give dot and then it will pick the Docker file. Now you see what it's exactly doing. It's doing all the step that is mentioned there in the Docker file. So you see it's what it's saying, that step by there is a step 0 it's performing. It's downloading the Node.js version that is there. Then there's a step 2 that is he's doing working directory setup. There is step 3 that is doing mounting the path, copying the stuff, and doing these things, right? Now there is some warning because this application is old one. I took the example from somewhere else. So some things are like actually dropped, but image is ready. So if I show you docker ps minus docker images, then you will see there is already my image hello example dot latest, and if the size of the application is 199 MB. Now let's clear this and let's run this application. So docker run, I will say in the detach mode, run it, and the application name is example, hello example. The image name is this. Now we also define port. So for example, on our, so this is the container port and this is the application port, because the application is running on 8080. As you can see, we have already mentioned it, the same thing. So when I do that, docker ps -a, if you see that there is this application is running, but now because there is some issue in the application, as we saw here, because of some key value should be instead of legacy this one. So because of this, it could be some things are not working. We can check the logs also. For example, if there is some issues, so we can check the logs. So let's see what happened to this container. If I just this one, you see what happened. So it says syntax unexpected token this at Node.js this. So it's saying that there is a port issue that is happening. Okay, let's say we don't have the port. We done this. Then docker ps -a, you see there are two applications now and its status is up. Right now this is the another application, this is another. The name you can see different. We have not provided a name, so it created a random name. We'll see it on how we can do that. So this is the actual app example. Let's go to the local host. So when I go to the localhost 8080, you can see that showing Kestra. Okay, just make, so I have to stop this application, Docker stop this one. Now if I do 8080 reload, see what happens. Okay, it's not opening. Localhost 8080, see, okay, it's not happening. Yeah, so as you can see, now I think this application is now running on, I think this is the very random port that it given, but we'll go and see that, because I think I forgot like how to allocate the port, but more or less we can go here, we can see that. Okay, so hello from Docker as it coming. So this is working properly fine, right? Now it's serving also. We can also see the logs of it, Docker logs of this container, right? Server started, right? So as you can see the logs. You can also follow the logs. I think you can stream the logs also. You can see what's happening. So for example, if I hit 10 times, right? I don't know whether there's a log setup or not, but yeah, server is started. There's no logging is set up on this application. It's very basic application. So yeah, this is pretty much that. This is how you can create images. As you can see, this is the image that we have created, right? And you can also push these images to Docker Hub. So what I showed you is this Docker Hub. You can also create your account here, but it's free platform. You can create account, you can push the images, you can share it with someone. You can also create private images for companies or for your private projects. So I think this is pretty much about the whole tutorial on the Docker Hub. I hope you understand. I hope it helps you to understand how actually Docker works and how we can use Docker. So that's all for now. We'll see you in next video. Thank you guys for watching. If you have any suggestion, you can comment down. And if you like the video, please. So if you like the video, you can hit the thumbs up button and subscribe to the channel for more videos like this. Thank you so much. Bye bye.